In order to operate a hybrid vehicle, first the vehicle must become ready. It must be put into a ready state. Starting the vehicle is covered simply because it's the very first event of hybrid operation. Now remember that the networks must be active. The networks must be communicating. They must be up and operating normally. It seems a little bit basic to discuss how to start a vehicle, but the hybrid is unique. A no start can be one of the most difficult problems you can have in your service bay, and this becomes very important when working on a hybrid after collision repair. Now this section covers important information for a no start condition. It also is going to show us the relationships between some of the modules. The power button is a push button momentary position switch. Momentary indicates that the switch is closed only as long as it's depressed and is open when you take your finger off the button when the switch is released. The switch has redundant contacts. There are going to be many redundant contacts and redundant circuits on the hybrid system. This is because on a drive-by-wire system, having redundant circuits is important for safety. The Power Source Control ECU has redundant power sources. It's going to receive those redundant inputs from that power switch. It's going to be supplied with a ground when the power switch is pressed. Here we have our schematic, and we're looking at the power source module up in the right hand corner there. Down here at the lower left hand corner, we see that B plus is supplied from the auxiliary battery, two circuits, AM1 and AM2, through the fuse links and the fuses. And as we see the drawing, we can see that it divides and it goes into cavity 33 and 12 of the connector for the Power Source Control ECU. And those circuits, once again, are called AM1 and AM2. They're redundant power sources for the Power Source Control ECU. AM1 and 2 are always hot. Startup involves a number of modules, with the Power Source Control ECU playing a major role. The Power Source Control ECU must always be powered, and that's so it can respond to the key being inserted into the key slot. Keep alive power. Here's the same drawing showing the auxiliary battery in AM1 and 2. We can see that the B plus has no switches, no control devices, and is always hot. The arrows are pointing to the fuses and the fuse links. When the key is fully inserted, the Power Source Control ECU gets a ground. And we're going to draw the circuit here so you can see that. When you push the key into the key slot, we're supplying a ground to CDSW. AM1 and 2 are always powered, so by supplying the ground, we turn the Power Source Control ECU on. The power button during normal operation has no effect when the vehicle's in motion. In an emergency situation, the hybrid control system can be shut down simply by holding the power button down for 3 seconds. If there is a no start condition, go ahead and perform a quick check of the key start system. The procedure is going to check the following: the security system, the key interlock operation, the power switch operation, and the auto park function. Check the security system simply by inserting the key fob into the key fob slot. If there's an optional smart key available, it must be close by to be detected. If the key fob security code matches the stored security code, then the security light will go out. If the security code does not match, the security light is going to continue to blink. If an ECU key or key fob has been replaced, go ahead and see the key registration procedure. Whenever you replace a key fob key or ECU, you have to let the security system register that new component. The power switch check, the action of the power switch is going to be influenced by the brake switch and the transmission selection switch. So make sure that when you're checking the power switch, you take that into account. The transmission must be in park to start the hybrid system, and the brake switch must be closed. You must have your foot on the brake to start the hybrid system. If you have the transmission in park with the brake pedal released, meaning your foot is not on the brake, pressing the power switch one time is going to select what they call the accessory mode, and the indicator light is going to be amber. By pressing the power switch a second time, you select the ignition mode. That's our basic key on, engine off mode, and the indicator light is going to be green. Pressing the power switch a third time simply turns power off and the indicator lamp goes off. If it's in park and the brake pedal is depressed, you have your foot on the brake. Pressing the power switch 2 times turns the hybrid system on and the ready light comes on. Auto park function: the hybrid system will turn off when the transmission is in park and the key is removed. It's called the auto park function. The system will automatically shut down accessory modes after 1 hour if the key isn't removed. If you forget to remove the key for whatever reason, the system will automatically shut down itself. And that's to save batteries from discharging. Remember, the smart key and the key fob keeps part of the electronics powered up if they are in position to alert the transponder key ECU that the hybrid may have an attempt to start. So what happens is that it powers up the different modules and that drains the battery. So remove the transponder key from the key slot. Keep the smart key at least 20 feet away from the vehicle so this system can shut down. The key interlock function. The key fob is locked into the key slot when the transmission is in any gear other than park. The power switch must be in the off or accessory modes with the transmission in park for the key to be removed. Power switch indicator flashing amber. Well, the power switch indicator is going to flash amber when there's a problem with the push button start system. Use the descriptions and the diagnostics discussed in this class to determine what the cause of the malfunction is. Looking at a circuit here, we see that we have the power switch circuit in the center of the screen. Let's blow that up and isolate the power switch and where it connects to the Power Source Control ECU. We said it has redundant contacts. Those redundant contacts are SS1 and SS2. Both contacts are pulled to the ground when the button is pushed, and it's going to make the connection for the circuit. Inside the connector of the Power Source Control ECU are cavities 37 and 14, and that is the redundant contact switch from the switch, and those are labeled SSW1 and 2. When the power switch is closed, the signal ST SW sent to the Power Source Control ECU to the Hybrid Control ECU, and that's called ST2. So if we look at the Power Source Control ECU, it is sending a message to the Hybrid Control ECU. The circuit on the Power Source Control ECU is ST-SW on cavity 39 of the connector, and at the Hybrid Vehicle Control ECU it's ST2 rather, and that's cavity 5. And you can see that when the Power Source Control ECU starts up, is powered up by supplying that ground when the key is pushed in, it tells the Hybrid Control ECU to wake up. The key slot switches. The process of starting the hybrid system begins when the switches located in the key slot close as the transponder key is inserted or the smart key is present. When fully inserted, that CDSW circuit we talked about is pulled to ground. There is another switch in the same key slot that goes to the body cluster, the body control module. The switch is for when the key is only inserted halfway. If the key is inserted into the key slot, this switch will close if it barely gets in there. And you can see that it reports and sends a signal to the body control ECU, and we have a special note here. The body ECU is inside the instrument panel cluster, so don't go out and look for an individual box there. The half inserted key switch is what this is called. This switch's signal is used for waking up the other modules so they can get ready for the key to be fully inserted. These key slot switches, both key slot switches, must be closed for all hybrid operation. If the KWW switch signal is received and the CDSW isn't, the key must have been inserted only halfway. And there's going to be diagnostic trouble codes for a half key inserted. So, if the top switch is closed, and that's at KSW1, and our CDSW isn't closed, the key must have been inserted only halfway, and a code will set. Inserting the key, you have to do it firmly and push it all the way in. The Power Source Control ECU will supply B+ to other modules when the key is inserted into that slot. As with any vehicle, security is an important subject, and it's no different with the hybrid vehicles. The security system is referred to as an immobilizer. It is used to decide whether or not to allow vehicle operation. There's two versions on the Generation 2. The standard version is the transponder key that responds to an oscillator coil inside the key slot where you insert the fob. The key fob has a chip inside which has a security code stored, and it's going to be retrieved by the key slot amplifier when the fob is inserted into the slot. The amplifier is going to detect a signal from the transponder key and then send it to the Transponder Key ECU, exactly like this. On the left we have the key slot, and you can see that we have the transponder key coil and amplifier in that key slot. On the right you see the transponder key ECU assembly, and there's 4 circuits there. The amplifier detects the signal from the transponder key and sends it to the transponder key ECU on that circuit labeled CODE or code. The other circuit is VC5. It is the 5-volt reference signal that is going to be present when the fob is inserted into the slot. The halfway switch is used to detect that the fob is being inserted into the slot. And as we said, the CODE is a digital signal from the transponder key coil that's going to be amplified by the key slot amplifier. The TXCT is a digital pulse that is sent when the fob is inserted into the slot, and a GND is the system ground. Testing these signals is best with a digital storage scope. It is best to use a DSO for checking these signals. The signal isn't going to tell you if the key code is correct, even if you use a DSO. It is going to show you if the code signal was sent to the transponder key ECU. Without a code being set, the vehicle won't operate. Set up and connect your DSO first, and then insert the key. The TXCT signal is sent when the fob is inserted into the key slot, and you can see that we're using above a 5-volt range, so we get the entire waveform in there, and we're using a 20 millisecond sweep rate. And when you look at that digital signal there on that waveform, that's what yours should look like. Check for noise. That's going to cause an error in the digital information. Noise is typically going to go above 2-volt level, but it's not going to reach the full pulse height. The sequence of events takes place when the key fob is inserted into the key slot. Now this is the sequence of events, the things that take place after you insert the key fob into the key fob slot. Number one, the amplified transponder key signal is sent to the transponder key ECU. You can see the smart key ECU on the left, the transponder key ECU on the right. Number two, the transponder key ECU matches the key code to the codes registered in memory. Number three, if the key codes match the stored key codes, the transponder key ECU turns off the security. Number four, when the power switch is depressed, the transponder key ECU sends the key matched information to the Power Control ECU. 5. The Power Control ECU turns on the accessory circuit and the ignition 1 and the ignition 2 relays. It turns on the power switch indicator lamp to amber. When we look at this drawing here, we see that the Power Source ECU is going to power up the accessory, and of course the ignition 1 and the ignition 2 relays. Now, the Power Source Control ECU sends a start system signal to the hybrid control ECU. See the hybrid control ECU on the left and the Power Source Control ECU on the right. And on the right we see at cavity 39, that circuit is called STSW. When it gets to the hybrid connector on cavity 5, it's called the ST2. After the hybrid control ECU confirms the ID code is verified, it bypasses the immobilizer system and starts the hybrid control system. This is the first system, and we said there are two versions of security used in the Generation 2 Prius. The other is the smart key system. It works with the key fob near or inside the vehicle. It does not have to be inserted into the key fob slot. It's not necessary to put it into the slot. This is a smart key system. It means that the fob is going to send a signal that is picked up by different components on the vehicle. So once again, it is not necessary to insert the key fob into the slot when you have a smart key system. Here in the lower left you see the smart key fob, and you can see that there's going to be different oscillators, and there's 5 of them, one on each corner and one in the passenger compartment, that's going to pick up that signal. The key slot's available if it's needed, but the oscillators are going to be located near all the entry points of the vehicle and one in the passenger compartment. The startup procedure is going to remain the same, only the key slot switches are no longer necessary. When the ready light turns amber, the vehicle has detected the smart key. First, check B+ and grounds to the ECU. When you have a problem, the transponder key ECU's grounds and powers must be checked. We can see that CPUB is always hot from the auxiliary battery. There are no switches all the way up to CPUB on the transponder key ECU. It is always hot, just like other systems that are always hot, and when they're going to be turned on, a ground is supplied. The ignition signals are switched B+, and when we look at these signals, they are very complicated on the circuit, but they're just wires that run from the cavity on the IG circuit from the transponder key ECU over to the ignition relays. The transponder key ECU signals can be gathered at the connector on the transponder key ECU. Pins 1 and 2 are not used. Pins 3, the CPUB, is the B+, that's always hot. We just talked about that. Pin 4 is the ignition B+, and it's switched and it switched battery power from the ignition to power relay. Pin 5 is the CUWS halfway switch closed when the key fob is inserted in the slot. It's under 1 volt when the key fob is in the slot. At least halfway. Remember, we talked about the 2 switches that are in that key fob slot, the halfway and the fully inserted switch. And of course it has 14 volts or B plus with no key inserted. Pin 6 is the TXCT key inserted signal, and it's transmitted when the key is inserted into the slot, and you can see it's a digital signal. Pin 7 is the AGND ground for the ECU. Typical voltage is going to be under 50 millivolts. Pin 8 through 17 are not used on that connector. Pin 18, HEV1, the hybrid control ECU input signal, and it's typically B+. Pin 19, the HEV0, hybrid control ECU output signal when the power switch is on. Pin 20, the VC5, is 5 volt power for the key slot. It goes between 4.6 and 5.4 when the halfway switch closes. Pin 21, the COD, that's the output of the key slot amplifier, and you can see it's a digital signal. Pin 22, the GND, the ground for the ECU, typically under 50 millivolts. Pin 23 and pin 24 are not used. Let's look at the key slot connector. These are the signals that you can measure at the key slot connector. Pin 1 is the VC5 signal, the 5 volt power for the key slot, and it goes to 4.6 to 5.4 when the halfway switch closes. Pin 2 and 3 are not used. Pin 4, the COD signal, that's the output of the key slot amplifier, and you can see it's still digital. The pin 5 is the TXCT key inserted signal transmitted when the key is inserted into the slot, and that's a digital signal. Pin 6 is not used. Pin 7, the GND, is the ground for the key slot ECU, and it's should be under 50 millivolts. Now the power switch is going to glow amber when the ignition relays close. The power switch light will glow amber. The brake pedal position is going to determine if it goes green to indicate that the hybrid control ECU is ready to operate the vehicle. If a malfunction is detected when the ignition 1 and 2 relays are closed, the amber light will flash and the hybrid control system will not operate. Let's not forget the brake pedal switch. There are 2 sets of contacts on the brake pedal switch. Once again, we have redundant circuits. The brake light switch signal goes to the Power Control ECU and to the hybrid control ECU. If the power switch is depressed without the brake pedals closed, you don't have your foot on the brake, the accessory mode is activated. The accessory mode powers the instrument panel, the navigation system, the audio systems, without powering the hybrid control ECU. The STP signal is connected to the battery voltage when the brake is depressed. If the key fob code matches the stored codes and the power switch is pressed with the brake depressed, the hybrid control ECU goes ahead and wakes up. Now there's scan data for the Transponder Key ECU, and we can see that the first one we're looking at is STR UN link SW. We can't cover all of the data in one single class that comes out of an ECU. These are examples. So when you need to look up something on your scan tool, you see STR unlink SW and you go, what the heck does that mean? On some scan tools there's a help button that'll help you. If not, look in your system information and find the answer. This is the on-off state for the steering unlock switch, on when the key is in the slot. The ready signal, on-off state, of Power Control ECU turning on Hybrid Control ECU or on when the Hybrid Control ECU is turned on. So instead of going to the connectors all the time, there's a lot of scan data that can be monitored. This is an on and off state, this ready signal. Now it's going to tell us when the Power Control ECU turns on the Hybrid Control ECU. And that can be simply viewed by sitting in the front seat of the car. Other scan data example is vehicle speed signal, the run-stop state of the vehicle, run when the vehicle control ECU is running, off when the Hybrid Control ECU is off. The shift P signal, on-off state of the park position, on park, off, not in park. ST RADYMON, on-off state of the starter relay, on when the start signal is on and off when the start signal is off. Now, just a note here. I have no idea what Toyota is trying to tell me with ST RADYMON. But when I go to my information system, when I go to the help button on the scan tool, it gives me this information. So don't panic when you see an acronym that you've never seen before. The ACC cut signal, on-off state of an accessory relay. On with accessory relay on and off with the relay off. There's additional scan data available, but as I said, there's just no way to cover all the scan data that comes out of these vehicles. You have to use your scan tool's help button or your information system.